Well, we started out talking about rocks last night, and now we got to see the problems in evolution theory. And so now we're going to get back to the fossil record to end with. Okay, what we're going to talk about is what is the nature of the fossil record. We'll talk about basically four things. What's the fossil record like? How long does it take to form a fossil? What could explain the sequence of fossils? And what conditions does it take to make the great fossil record we have? This is a group of students excavating fossils in Wyoming. There's so many wonderful fossils. It's just fascinating to dig them up and try to understand them. And they're such beautiful fossils. These complicated trilobites with all these horns, structures. This is the oldest known fossil bat. You notice it's a fully formed bat. There's no evidence of evolution here. Fossil leaf, and this turtle. These turtles can be, really long and complete turtles. What does it take to make a fossil like that? What does it take to make a complete dinosaur and have it preserved this way? Okay, there are a great variety of living animals, so many kinds of living animals. And the fossil record is full of not only these kinds, but an enormous variety of creatures that are lost, that are now extinct. And you notice here trilobites, and you have fish, different from any we have now. This strange reptile with his fin on the back. Dinosaurs, many kinds of dinosaurs. These are flying reptiles, pterosaurs, up to the size of a small private airplane. Saber-toothed cats with their big teeth, and this is a Volkswagen-size armadillo-like creature. So many kinds that are extinct. And so keep that in mind as we talk about fossils. And the first question we're going to ask is, how long does it take to fossilize an animal or plant? Now, years ago, you'd commonly read in books, well, it takes millions of years to make a fossil. That was just an idea based on the theory of evolution. But in the last few decades, there's been a lot of experimental study about fossilization. And now a whole lot more is known about fossils. And you no longer see those statements that it takes millions of years to make a fossil. This is one of my favorite fossils. This thing sits on my desk at home. I didn't bring it with me, but it's a little rock, has this fossil in it. Any guesses what that is? It's called a coprolite. Coprolite is fossil dung. It's probably crocodile poop. Okay? So this thing, it's about that long, and it's in rock that's in fine layer. This is a microscopic view of the side of this rock. Many very thin layers, and this is fish coprolites, small ones. And there are all these layers, and most geologists think that those layers form about one layer per year, maybe a few layers, but not many. But this coprolite is in a rock that has 180 layers in it. Okay, so what's the chances that this thing lay on the bottom of a lake for over 100 years and is beautifully preserved? There's just no chance. Something is wrong with the understanding of these layers. This had to have been buried very fast. And it's now understood that fossils form quickly or not at all. Something dies, you better bury it quickly, prevent decay, or prevent the bones from being separated and scattered around. Otherwise, it's not going to make a fossil at all. So that's the answer to our question. You either fossilize it quickly, or it isn't going to be preserved. Fossils they can be bones with the spaces in the bones that are filled with minerals, or it can be not mineralized, but just bone preserved. Here there's no bone. It's basically soft tissue, and yet it's preserved. Or a fossil can be just an impression in the mud. There are many types of fossils. So you have to form them quickly. That's one, and that fits nicely into our understanding of Earth history. It doesn't take millions of years to make a fossil. It has to happen fast. So question number 2. And this is a question we don't really know the answer for. What is the explanation for the fossil sequence in the geologic column? So this represents these layers of rocks, one on top of the other, and this is like a history book. You can't make layers of rock and then slip another layer underneath. So the lowest layers were there first, and then the other layers come in order above that. And so this is like the order, the sequence of rock layers and the fossils that are in them. And we get to the rocks formed most recently. Those are the ones that have people. There are no human fossils in the rest of this record, only up here. Our more familiar birds and mammals and things are up here, not down here. These are different. The farther you go down, the more different the organisms are. So why is that? That's our question, and that's one that we don't have a really good answer for. So how was this sequence formed? Now notice one thing here. Fish appear pretty early, right down in here. And then you get amphibians, and then later reptiles, and only up here you get birds and mammals. And our familiar types of animals are up here, and then finally humans. Why does it look like an evolutionary sequence? This is the question we don't really have a good answer for. But we're going to talk about some ideas about how it could come about that way. And there are other details that are interesting. Here's a sequence of rocks in Utah. And you look on these rocks, and you look through the details of these fine layers of rock. And in animals like this is an example of a phenomenon that we see commonly. These are called ammonites, and each of these lines shows where one particular species is found. So here in this lower layers you find these species. Later on you find different species, and higher up you find different species, and so on. So why are these species in different zones like that? What is causing that? Let's look at alternate explanations for this whole thing. First of all, of course, this is the accepted theory. This is a record of evolution through millions of years. So there are no mammals here because they had not evolved yet. That's the prevailing theory. Humans are only up here because we didn't evolve until way up there. Okay, the other possibility is this is a sequence formed in the global flood. So in that event, these rocks are being laid down one series after another. These get laid down first, and then these rocks, and then these rocks, and so on. And somehow that sequence during the flood gave us that order of fossils. So how would that work? Well, we'll look at some possible answers, but keep this in mind. We have never seen a global flood. We can't really envision how that would work. And so some of our questions really cannot be answered now. Don't expect to have all the answers, but we can find some helpful clues, and we'll talk about those. Okay, here's a beginning of an explanation of how this might work. This would be a reconstruction of what the pre-flood Earth might have looked like. So you have ocean, and you have sort of swampy areas along the shore, and then you get higher up and find the higher elevations. You have dinosaurs living in here, and unique kinds of fish in here, so on. And we'll get to this part later. But over here we have, this will be a sequence of accumulating rock formations developing during the flood. And so in the first step here, this lower habitat now is getting destroyed during the flood, at the first part of the flood. And these fish, these interesting fish that live there in the bottom, are getting buried over here, and this habitat is being destroyed. So now that habitat is destroyed, and it's preserved over here. Now the next habitat is being hit and being gradually destroyed, and its creatures buried over here. Okay, then you get to the next one. Again, so this is happening one habitat after another. And these habitats are not being restored after the flood. And so that's why those animals are extinct. But now, let's talk about this one. What's happening over here? We have to have this column because of what happened during creation. Now, end of creation week, we've got what? We know we have creeping things, we have reptiles, we have mammals, we have humans, we have fruit trees. All these things are there on the earth at the beginning. But they're not here. And so they must have been living somewhere on the earth where fossils were not forming. You don't form fossils everywhere. Right now, up in the hills, you don't form any fossils. The only possibility is down where water is depositing sediments. But even now, fossils are not really forming, except under very strange conditions. But somehow these things were living somewhere, not being fossilized. And we don't know really where that was. But it had to be that way to explain the evidence. But we continue on. You destroy the next habitat over here, and then you start catching these animals that are living higher elevation. And so it goes. Finally, you start getting creatures that probably have come out of the ark after the flood, and they're distributing around the earth. And now you're fossilizing some of those. The flood is over, but things are probably still rather catastrophic on the earth, and you're making these other fossils. And then you get these that are clearly after the flood that are being buried. So now we have this sequence of events. Each habitat, one habitat at a time, is being destroyed and fossilized, so on up, until finally you get the post-flood animals, plants, buried. Okay, have we answered all the questions? No, we clearly haven't. This is the beginning of an understanding of how this would work. But like I say, we've never seen a flood. How could we answer all these questions? It's a good beginning, but there have to be other important factors that influence when an animal becomes a fossil. And we can look at some of those, get some ideas. So when in the flood, this diagram will illustrate when in the flood does an animal first get killed and buried. So when do fish first get killed and buried? And will that happen to fish before mammals and before birds? So that's what these numbers mean. Fish are more likely to get killed first. Now we have fish all through the geologic column. When do the first fish first get buried? That's what this means. So they'll probably get buried before birds and mammals. So let's look at some of the reasons why this would be. One would be ecology, where they live. Something living in the water is probably going to get killed in the flood and buried before something living up here in the mountains. So ecology will affect it. The next thing is behavior. Which one is more likely to have the behavioral adaptability to escape longer? This salamander or this wolf? Well, behavior can make a very big difference. And just for giving an illustration, fish and other creatures living in the ocean, if there's some unusual thing happens, some catastrophe, some disaster that happens, what are they going to do? They'll probably dive down the bottom and hide. Okay, that's not going to help them very much in a catastrophe. I'll give you another example of how this works. There are friends of mine who study insects, and they go out and they collect beetles, and they do what's called beating. They have a frame about 1 meter square, 1 yard square with a white canvas, and they hold that under a tree, and then they'll beat on the branch with a piece of wood. Okay, and beetles will get knocked loose, and a beetle's natural behavior, when that happens, it will fall to the ground and just hide, just stay still. Well, that's not going to help it when you got a white canvas underneath it. Okay, so your behavior has to be adapted to really help you. And during a catastrophe, simple behavior will probably work against you, while a creature that is more behaviorally adaptable have a better chance of surviving longer. And just mobility. This guy is also not able to escape quickly, whereas a bird can fly away. So mobility will have an important factor. In each of these cases, these what we would call simple animals are less adaptable and will probably get killed first before the birds and mammals. So we get it to an average here. This kind of is the way the fossil record fits. We have fish first, then amphibians, and then reptiles and mammals later on. So this can have an influence. Does it answer all the questions? No, but it's a beginning. Something else that I believe would affect it, perhaps would influence why these species are in different levels of the rocks. If you've got a catastrophe like a flood, it's going to start tearing up rocks and putting them into the water, putting a lot of chemicals in the water, and as the water is going to keep changing. And if different species have different levels of how they can cope with these changes in the water, this could influence when they die or how long they live. So there'd be probably a lot of factors like that would influence what gets buried, when, in what order. But do keep in mind, we've never seen a global flood. Some of our questions can't be answered now, but we can get some helpful answers. And so that's what we work on. And what I've showed you so far is kind of a beginning of an understanding of how this might have happened during the flood. Now let's look at the third question. Are evolutionary intermediate fossils common? So you've got reptiles and you've got mammals. So you have a whole series of fossils that show the evolutionary sequence from reptiles to mammals. That's what we're talking about. Now Darwin understood very well that the fossil record did not fit his theory because you didn't have these evolutionary intermediates. And he puzzled over this. Why is this? And he came up with an explanation. He said, well, it must be that we just haven't looked enough. We keep looking, we'll find those intermediate series of fossils. The problem is that we've been looking now for 150 or so years, and the problem is worse now than it was for Darwin, because we found just an awful lot more fossils, but they still fit in specific categories. A snail has always been a snail, a worm has always been a worm, etc. You don't have the intermediates. We'll look at a few, there are a few sets of vertebrate fossils that are interpreted as intermediates, and we don't have time today to go into those in detail, but there are some odd groups that can be interpreted as a series of intermediates. But these are only a few cases like that, and some of them are not really that impressive when you look at them carefully. But look at the overall picture. This represents the fossil record: Paleozoic, Mesozoic, Cenozoic. So this is the division at the bottom of the Cambrian rocks. We don't find complex fossils below this, with a few rare exceptions. If this really represented the evolution theory as it's understood, the first thing, you should have a few kinds of creatures. And they begin to vary a little bit and more different. And finally you could evolve maybe a new phylum, maybe, vertebrates, and then later on you evolve a new phylum, starfish, and so on. You should evolve these new phyla gradually, one after another. Well, the fossil record is exactly the opposite, which is a serious problem for evolution. Here at the beginning of the fossil record in the Cambrian explosion, you've got just about all the phyla of organisms right there. How did they all of a sudden appear all at once? And you notice the dotted lines, this is the presumed evolutionary connections, but they're all dotted lines, meaning they're theoretical, not based on evidence. Phyla appear all of a sudden, and you only have small variations after that. So that's the opposite of evolution, and that's what we would expect in a creation and flood scenario. I was at geology meetings once, a few years ago, and they had some lectures dealing with this question: how do you get all these kinds of animals? And the paleontologists know the fossil record, and they know that you don't have these fossil connecting links. So they're trying to figure out, how can you evolve these different phyla very quickly? The biologists, on the other hand, they understand you can't evolve those phyla quickly. You have to have at least a 500 million years of evolution before this to make all these phyla. And so they had discussions at noon called hot topics at noon. They often have this. Controversial topics, they started to argue about them at noon. And so you had these two groups, each giving their arguments, and trying to understand why you don't have the fossils. When the biologists say you have to have, it's going to take at least a 500 million years to evolve all these, and yet there's no fossils. And I remember it came to a question and answer period, and there was one gentleman, I wish I knew who he was, sitting up ahead of me. He's sort of a distinguished looking gentleman, he probably a geologist, and he stood up and he said, you know, you're telling us that you have to have a 500 million years of evolution, but there are no fossils. And then he, with some emotion, he said, why are we avoiding the real question? And he sat down. And I presume the real question he was thinking of, did these really evolve? He didn't express it, but that is a puzzle. It just doesn't fit evolution. And the series that are interpreted as intermediates are rare and really rather doubtful. And so Darwin still has a problem. The record still does not support his theory. What conditions produce a rich fossil record? There is such a wonderful fossil record. How does this happen? Fossils are often very abundant in ancient rocks that look catastrophic from the flood or right after the flood. So lots of fossils in these old rocks that we talked about on Friday that look so catastrophic. But in the modern world, fossils, terrestrial fossils and even the others, you just don't see fossils forming today, except under very unique conditions, like tar pits, where they can fall in and get preserved in the tar, or in peat bogs. There have been a few people found that fell into a peat bog, and the acid conditions preserved them. Okay, it takes those very unusual conditions today to make fossils. You just don't have a fossil record forming today. Something had to be different to make a fossil record. And let's look at what happens today. These wildebeests in Africa are by the millions, I guess, and they have these long journeys they take every year. They have to cross a lot of rivers, often flooded rivers, in its dangerous conditions. And a lot of them die. In 1 year, there were about 10,000 wildebeests that drowned in pileups in these rivers. They miscalculated the conditions in these rivers, and so you have all these dead wildebeest. Should be a lot of fossils, right? Well, this was studied carefully. None of those became fossils. Bones decomposed beyond recognition within about 10 years or less. So you just don't have the conditions today to make fossils. So what does it take? Fossils, again, are abundant in ancient rocks that look catastrophic. And I believe those are from the flood or after the flood. So many fossils are intact and well preserved. So there's such a contrast from what happens today and what we find in the rocks. There's something important going on here. All these beautiful skeletons, and these would not be there unless they were buried very fast. These beautiful trilobites, such detail. And this one is a one I have in my office. It has the soft tissue preserved, the antennae, the legs, all these soft tissues are preserved. That was buried very, very fast. There are fish, Brazil, that are preserved in 3 dimensions. They're not even flattened. They're 3 dimensions. You can study the internal anatomy. And I read a paper on the taphonomy, how those got preserved. And they figure they had to have been buried and mineralized within like about 9 hours. I mean, fast, very fast. These are soft tissues, and yet they're preserved. This one is really pretty much soft tissue as well, and yet they're preserved. And there are a lot of fossils that show catastrophic conditions. You go out to the beach, you don't see creatures living in accumulations like this, or like this, or like this. These are under conditions that were accumulating fossils in masses, these mass mortalities. Here's some more. And these are something called nautiloids. They're kind of long creatures. And you see how they're all oriented the same way? That shows they were deposited by flowing water. And there's a huge numbers of these like this. Catastrophic conditions. This one is on the wall of my office. It's a beautiful creature, complete skeleton. Look at all these bones intact. Just amazing. More and more the whale we talked about and this bat. Here are two reptiles close together. Plants, beautiful plant. This is from a quarry up in Wyoming. One of our geologists in my department studies this formation, the Green River Formation. And I was up there with him one time, and we were at one of these big quarries. And the people there were telling us they had just uncovered a slab. It had a huge palm frond, a very big one, with fish around it. And they had this uncovered now to where they could collect it. And that would bring them about $100,000. So they went home to lunch, they came back, and it was gone. Somebody had obviously been watching them and came and stole that fossil right at that point. Beautiful fossils. So, what's the answer to that question? The fossil record speaks loudly of catastrophic conditions, and I believe that has to be the flood. And I would say most of these paleontologists, evolutionary paleontologists, they have no idea that the reason they have this wonderful fossil record to study is because of the flood. I simply don't believe you'd have that fossil record otherwise. It takes catastrophic conditions to form fossils, and it's not happening today. So conclusions. Fossils were killed and buried rapidly. That was our first question. It doesn't take a long time to make a fossil. It has to happen fast. Fossils are buried in a definite sequence. And so the interpretation, I believe the sequence resulted from conditions during the flood, although we don't really understand it adequately. Evolutionary intermediates are rare. That doesn't fit Darwin's theory. What will preserve numerous fossils? In ancient rocks, fossils are very numerous. Today, you just rarely ever make a fossil. Something is very different. And fossilization usually is in a catastrophe, and the best candidate for that would be Noah's flood. So, thank you.